How you doing today, guys? This session or this YouTube video, we're going to discuss CMMT-AS, a Festo product, parallel axis, synchronous position absolute. So we're going to gear in both these motors here and the axis, of course, for a rigidly coupled system. And we're going to use what Festo calls the mode synchronous position absolute. Okay. If I look at a layout of what I have two CMMT-AS multi-protocol drives that are configured for EthIP, and the connectors on the face of the unit X10 and X3. These are the interfaces that are used to either emulate the encoder signal from one device to another or to receive the emulated encoder signal. They call it position absolute, but it's still an incremental signal. So if you power down the axis and power back up, you will need to make some slight adjustments with your code in the controller. But basically, I have this interface set up here. So I have a PLC here, managed switch, of course, for EthIP, and the X19 on the top, these two ports right here, these are, in fact, the real-time ports, so that would be where you're communicating over EthIP. And the X18 ports are used to configure the axis with the software from Festo called Festo Automation Suite. To further discuss the wiring, I'm going to move to an application note here. This application note is on the Festo website. Hopefully in my YouTube video I'll have a link at the bottom either to this application guide or to a zip file with the actual guide in it. And inside the guide here, let's just continue to talk about wiring. So it's important when you are zoom in here. It's important when you have MasterSlave here that you have some sort of monitoring of both the slave and the master encoder signals, and like the emulated encoder signals, as well as the slave axis state. And if we talk about the encoder, basically what we have here in this project set up is we have a motor encoder. Okay, inside the motor here, each one of them is an encoder, and that comes back on this cable right here, goes into X2. And the idea of this guide here is that the encoder signal coming through on X2 will be sent out on port X10 and emulated to the slave, and that's received on the X3 port on the slave. And similarly, the slave axis, the motor on here, will come through on the X2 port and be emulated out on the X10 port coming into the X3. And the idea behind that is, with this arrangement, the Festo controller can look at these two signals here and be constantly monitoring for a difference of position. Okay, and that'll be discussed later. The additional wiring we'd like to discuss here is we have a enable signal that is on the master controller. It's called control enable, this signal right here. And on the slave axis, we have a ready signal. And anytime that the slave has some sort of a fault or something along that line, the contact of ready C1, C2 will open, and in turn drop the control enable on the master. The master will then respond, and the slave will follow what the master does. So this wiring is also implemented. Sorry, I don't have a better CAD drawing or something of more concrete. You'll have to do that yourself. But basically, those are the two important things that we need to monitor. The control enable signal, which is the ready signal coming back from the slave to the master, will drop out the master, and again, the encoder wire. The idea behind this is that whenever there's a break detected, the slave will issue a warning, and the master will see the differences and cause a fault and stop in whatever the manner is programmed while the slave follows that. If for some reason the slave is not able to simply stay in a warning state and go into error signal, that's when the signal right here, this enable here, this will be dropped, the ready signal, and again the master will respond accordingly. So that's the gist behind the wiring. Next thing we'll do is go to the website for some software to configure the Festo CMMT controllers. Okay, so we're going to go to the website here for Festo. We'll type in CMMT-AS in the search window here. If you don't want to do what I'm doing here, it's just www.festo.com, and type in your controller name. When you do that, you'll come to this web page here. You go to downloads, then you go to software, and right here you'll find that they have the Festo Automation Suite. This itself is the overall package. This software is meant to be used for many Festo product. So this is like the house, and then we have plugins. The plugins are the different devices and whatnot that this Festo Automation Suite deal with. So in this case here, we are dealing with the CMMT-AS. So we will download this 24123 along with the Festo Automation Suite, and at that point we will install those. The Festo Automation Suite gets installed first, and the Festo Automation Suite plugin gets installed on top of that. Okay, so we've downloaded everything and we put this in a directory somewhere. And the directory here, so this file right here and this file right here. So this file right here, the one right below the line, this one, okay, that one right there, and this one right here. Okay, the Festo Automation Suite 250.635. Okay, how do you install that? Well, you simply run it as an administrator, or just double click it or run it. And it's a pretty quick installation, and I'll open that up now. Okay, so I'm gonna make like I've installed this already, which I have, and I'm gonna open up Festo Automation Suite. Okay, so you've got the blank project, and you can come up here and say save, and then you can give it a project name. You can offer some description text. I like to come down in the corner here. If I double click on this Festo Automation Suite here, double click, and then come back up to the project settings here, edit. I can paste this in here, which gives me all the plugin information and whatnot. So you basically copied all the versions of everything you're using. That way you know for future use what you're using in the project. Now we're at this blank project here, and now we want to add our controller. So there's a couple different ways you can go about that. You can right click and say add device, or you can come over to the side menu here. If you have brand new controllers and they're blank, you can drag and drop. So in this case here, or you can go to controllers. No, not controllers. Where is it here? Ethernet IP device, electric drives, and then you select your motor controllers here. So I always like to start a project from nothing. I don't care what's in the controller. I want a fresh project that's going to override everything. So I'm going to do that. So first thing I'm going to do is I'm going to paste in the part number of my device, which is my master. It comes up with this part number right here, and then you simply click and then hold down the click button on the left side and drag. Okay. On the right side, on the slave side, I'm going to use a different controller. It's the multi-protocol, as I said. I'm going to click and drag over. Alright, so it looks slightly different. And the first thing I'm going to do here is rename the controllers, because I don't want to make any mistakes here. So this is the master. I'm going to say rename. Come on. Paste. Okay. And I'm going to do the same thing for the slave axis. Okay, and I can do the same thing by selecting over here. Okay, so now I have CMMT-AS, actually the EP. I'll just leave it as MP, whatever. So now we have the two devices in our project, and now let's start by configuring our master. So if I double click this device, it's going to start up the plugin which we've installed earlier. Okay, you'll see some orange color looking things here. Just ignore that for the time being, because we need to configure the hardware of the system. So we're going to either click right here on the first startup, or the start first setup, or we'll click right here. Both amount to the same thing. And the master, we're going to just follow the steps here. Okay, we're going to add a motor to the controller. My motor is this particular one right here. I hit apply. And add an axis. This is I'm just taking this from my bill of material here. And then I have to match the type code, because there's a variant type. I have an EGC70 TBKF 0HGK. That's this one right here. And the working stroke is 175. Additionally, I have a gear between the motor and the axis here, so I need to configure that gear. This is the gear right here. Hit apply. It will change the mounting kit to adapt, and this should match your hardware. Okay, now we move on to the next step. We can hit the next button, or we can hit the device settings here. My voltage. Okay, we're going to start just modifying the obvious things here for general setup. So I have 120 volts, and in my case, my IP address I need to match, which I've already provided to the device. I'm going to make sure that Telegram 111 is selected, and I'll leave the defaults the rest. Hit the next button, and application mask. In my case, I'm not going to match what you have. I have to select the position of the motor. I have to select whether I need to invert the travel distance, and then I move on to the next. Hardware settings, I'm not using a reference. I'm not using limit switches. It's not recommended to use limit switches for this. Well, I guess you could, but well, for the master you could. Anyway, we move on to the next one here. This is just general. We move into the homing position here. The simplest homing method is current position and with no movement. Okay, so I'm going to turn off the movement here, because when we're doing a rigid system here and I home or reference the axis, I want the axis to home where it is or reference where it is in the exact location it's in. I don't want it to move to some location after that. Then if we hit the next button or the software limits, now we're going to move into this one here. I'm going to, for now, turn off the software limits. Well, I guess I could leave the software limits active on the master here. I can leave them on here. The axis 0 point is in fact 0, 0. So I'm going to change that to a 0. And now I can say finish. So it's going to take all the hardware and take care of all the things inside the code that were orange, which are kind of warnings. If those orange labels were still left, you would have this correct parameters option up here. And like described in the application guide, you could go in there, see what the differences are, and then accept them. But we're at a good point right now, so I'm going to do the exact same thing for the slave. I'm going to double click the slave. Okay, again, we hit the start first setup. Then we're going to add the hardware that we have purchased. Okay, I have this motor. Apply. Come to the axis. And sorry, I clicked the wrong button here. So again, the axis. And it's this one right here. Okay, this is a really important fact here. For my hardware, I have purchased again another 175 millimeter stroke axis. I am actually going to type in 200 millimeters here, because at no point in any time when we're geared in or synchronized with the master do I want the slave to encounter a stroke limit or an over travel of any point, because that takes the axis out of synchronization. So by entering this 200 millimeter stroke, the tuning parameters and whatnot are still calculated properly in the software, because there's a physical stroke, and we will never reach this 200 millimeter stroke. So I'm going to apply here. And again, I have a 5-to-1 gearbox again. Select that, apply. Okay, hit the next button. And again, I have 120 volt connected to my drive. You'll see here that the interface is slightly different because this is the multi-protocol drive. The next button here, Now we're into the field bus. This is where we need to select our EthIP or whatever we're using. In my case, I'm using EthIP. Make sure that Telegram 1 is turned off, and we're going to select Telegram 111. And we are going to modify our IP address of the real-time port. And just to make this clear, the real-time ports are the top ports here. So both these ports, this is like a switch inside, this daisy chain, but we are configuring the X19 port just like you see here for 224, and in my picture here I've got the master and slave ports backwards, but that's irrelevant. You get the idea. Okay, so hit the next button, and we're going to get to the rotation polarity again. We're going to put in our load, and again we're going to select our axis rotation or inversion. Hit the next button. I'm just going to keep this the way it is. I'm not using any reference or limit switches. Homing method. The homing method, again, we're going to turn off move after the axis, and we're going to select current position. Why? Well, when we have physically lined up the master and the slave axis, the master's already been referenced, and we're now going to be referencing the slave. Because we have that perfect alignment, when we execute the reference or homing method, we want it to be the exact position it's in right there, because that's the perfect alignment. And we don't want it to move afterwards because we're physically attached at that point. So this is what we're going to leave here. Hit the next button. We're going to change this to a 0 because that's the position I want it to be at. I'm going to disable the software limits. Disabling the software limits is dependent on your application, but in my case, like I said, I don't want to ever experience a software limit on the slave. It's fine if we encounter that on the master because the slave is following the master and will stop. But when it comes to the slave, an over travel of any sort will take the axis out of gear for synchronization, and I don't want that. And finish. And right now, I guess the next step would be, if we go back to the master real quick, this little path right here, this is going to select the device and the IP address already. You can also right click and change network settings in this pop-up window here, but I've already done the assignment of the IP address, and I'm going to configure this as the 184. So now that's changed this to there, and on the slave it's 223. So now we've just configured our target to connect the software to the device on the X18 port, which is the X18 port on the front here. Okay. Okay, so now we're going to start making changes to the default configuration or the general configuration for the axis, and we're going to start with the master. Okay, and we'll just move down the page here on the left. I'm just going to expand this here. Field bus. So we have this field bus extended process data, and what we want to do here is there's standard process data, which is used to control the axis, and the control of the axis is done through Telegram 111, which is basically EthIP is basically Profinet over EthIP on this particular controller. So Telegram 111 is an arrangement of bits and bytes, and that's called the standard process data. And then we have this extended process data where we can configure our own parameters and whatnot that we want to send to and from the controller. Okay, in my case here, I'm going to add a couple of variables, and I'm typing this in by copy paste, so that's a little quicker for me. So this right here is position window monitoring, We can't see that. Basically, this is what we're going to be used. This parameter 4643 is going to be the position tolerance window for the cross wiring of the X10 to X3 signal. Okay. The next signal here is going to be me looking at, come on, the actual position. So the actual position encoder channel 1. I'll explain that again in a little bit here. And then we're going to add another one here. Absolute position. Okay, so this is the sent data. So these parameters here will be being sent from the controller to the PLC. Okay, and that's all we have to do here. The actual position encoder value 1 and here, these are, if you go down to encoder interface, we might cover this again later in detail, but encoder 1, this is in fact the naming inside Festo Automation Suite here is a little bit strange. Basically, encoder 1, which is port X2. Okay, so this right here, port X2. This over here is port X3. This is port X10. Okay, very important to understand things. Basically, so encoder 1 X2, the position 11.601.00, that's absolute position. The 128 is the exact same value. Okay, and again, the X2 port is the physical encoder signal coming from the motor. Okay, and the last one here was 11.601.10. That is 11.601.10. That's the absolute position of encoder 2, which is X3, which is X3 right here. Okay, so it's the encoder signal, it's what's receiving the emulated signal from the opposing controller. Okay. All right, so we've done the extended process data, and now we're going to move to the encoder interface and configure this page, because this is really important. Okay, and in order to configure this and have some understanding about it, I'm going to open up the same page on the slave, because as I explained, we're configuring the cross connections here. Okay, and the encoder interface 2 has a feed constant, and the default of 1000 is incorrect. Encoder interface 2 is talking about this encoder right here, and this encoder right here is coming from the slave, or we're on the slave, sorry, go back to this one right here, we're on the wrong one, so I made a mistake here. So we're on the master here. Again, the interface 2 is the X3 port, and if you look at the picture, the X3 is always coming from the X10 port of the opposing device. The X10 is the actual encoder emulation. The X3 is receiving the signal. So whatever the encoder signal is here, the scaling, the feed constant must match that. So in my case, the feed constant of both master and slave is the same for the axis. The feed constant is 78 millimeters. Okay, so it's right here. Feed constant of the axis is 78 millimeters. Okay, so that is the same on the slave, same on the master, okay, in this particular case. So in my case, we're going to type in 78 here, okay, and next we're going to configure what encoder 2, which is X3, is going to be, and when we're doing encoder emulation, we are configured as an incremental encoder. So we modify this to the incremental encoder, and then we need to come up with a resolution here. The default is 5. We're going to type in 16382. 16384 is the max. If you do that in some versions of this software, you can corrupt the controller altogether. 1683 is a oddball number. It's an odd number. I don't like odd because it doesn't do calculations well, so I'm going to use 16382 in all circumstances. I'll get to why that's configured like that in a second. But basically, when we come down, the X2 encoder, or the encoder 2 X3 port is configured now, and with the X10 port now, which is configuring the encoder emulation itself, this is where we use the same resolution, and this will be the same resolution used everywhere. So 16382, which will be set up in the slave as well. So basically, that is set right now, and we're good to go. The maximum here is 16383. Okay, so the encoder interface screen is completed now, and I'm going to hit the save button so that we don't ever lose this information. So let's go to the next thing, and we're going to move down to this MasterSlave down here, and we are going to configure this right here as encoder interface 2, which is the X3, because this will be used in the crosswire monitoring. Okay? Nothing else here needs to be configured. Okay, the next thing we're going to go to is the parameter list. And if we've never been into the parameter list before, this is every single parameter that's available in the controller, and we have this search field up here. And for the sake of this guide here, we can go about this a couple different ways. So if you type in a parameter that you know, p1.4643, you will see here that one specific parameter will be shown. Okay? You'll notice here also that this particular parameter is part of this group. So now if I take this and write this group in and type that in, then the entire group and all the parameters within the group are shown. So in my case here, I'm going to leave this group here active in the filter field, and I'm going to look for 4643. Okay, so this and this. These right here, these values are very, very important to our encoder cross-wiring tolerance. Okay, we have this monitoring window, encoder monitoring, so this is in meters, and let's see if I can make this a little clearer for you guys. But basically, okay, so we have this one right here. We have this one right here, encoder monitoring window, which is meters, and then we have this damping time, which is basically saying, hey, when I'm comparing the value of encoder 1 to encoder 2, what is my tolerance allowed in meters? So, 1 or 2 millimeters depends on the project, but you want the number as small as possible. That way, if the encoder cable has failed or whatnot, the detection is that quick. And the encoder time is how long does this position window need to be here. Okay, so in my case here, the default is 0.001, and that's not very good. Well, 0.001 is 1 millimeter, so maybe we can leave that the way it is. Again, when you finish setting up your project and you're optimizing everything, you might want to come back here and lower this, or if you have high velocities or the gains aren't so properly set up and tuned, then this value here might actually need to be increased. And then the window here, 0.1 second is basically 100 millisecond, and I'm going to modify this to 0.05, which is 50 milliseconds. Okay. Okay, so we've set up the window and we're complete with that. Now that we've done that, then we want to set up the error classification for the encoder monitoring. So let's go to the control tab here, our diagnostics, error classification, and we want to find error 133. So let's scroll. Okay, here we go. I'll zoom in here a little bit. So error 133, this error right here, is position difference encoder 1 to encoder 2. And it's set to ignore. So if we recap here, the encoder 1 to encoder 2, so go to the encoder interface page, encoder 1, X2 port, X3 port. So we're comparing the physical absolute position coming from the motor on X2 port, and we're going to compare that to the X3 port. And the X3 port is what's being emulated from the opposite controller. Okay? And what we need to do in the master is we need to modify this so that it's not ignore, it's a stop category 2. And the stop category 2, basically when you encounter an error, the drive will be decelerated using a parameterized stop ramp as soon as any error occurs, and once it's reached the 0 speed, the closed loop controller maintains the drive at the position achieved. Okay, that's my preference. Your application could be different, but it's extremely important that this be configured here so that a response of the monitoring is going to take place. Okay, so the next thing we're going to do is the trace configuration. This is for troubleshooting purposes. And I'm just going to set up some values here real quick. You can modify a signal just by doing what I just did there. Change the trace channel. You can delete. Yes, delete. Just going to delete the rest of them here. These are all default, or I can hit. I'm just going to delete all. How about that? Okay, so I'm going to add a trace channel. And I'll add a few more here. If you don't know the number and you're trying to find something, you can search by the name of something. So this one here is called error active. So if I type in error, then quite a few things that anything that has the word error in it comes up. If I get out of that and go back out, there's frequently used, and error active is right there. So there's a couple of ways of adding a trace. Because I know what I'm looking for here, I'm just going to copy and paste the values. And the last one here is 171. Okay, motion manager status. And then at the bottom here, we set up a duration of the trace. So 4 seconds I'm going to allocate here. And then if I scroll down, what I want to have here for a trigger is a fault acknowledge. Let's delete that and then add a new trigger. Rising edge, active of course, change the trigger. And this right here is the time. So when the trigger occurs, it will record half a second or whatever this value is prior to the trigger. Okay? All right, hit the save button. Okay, so now the master changes that are required for synchronization are complete, and we're going to move into the slave. And as in the first steps of the master, the first thing we're going to look at is the extended process data, and we're going to add some parameters here. So as before, we're going to click on that, paste in the value that we want, wait for the refresh or the data to be found, position monitoring window, P, come on. I don't know why it's so difficult to get this to work, but it is right this second. And come on, find the value here. Okay, apply. That's X2 encoder. This is X3. And then the last one is the slave synchronization status. Apply. Okay, so hit the save button. Okay, we're going to move to the encoder interface now. And I'm just going to minimize this a little bit because it's easier to compare what's going on left to right. And the encoder 2, which is the X3, which is the X3 port right here, coming from the X10, and as we showed you earlier, that's being emulated out of X10 based upon this axis right here. So it's a 78 millimeter constant, feed constant. And I showed you this before, but the feed constant is right here on the drive, 78 millimeters it should be if this refreshes sometime, and it's right here. So 78 millimeter feed constant right here. And with that in mind, the master is also that, and therefore this right here, because we're setting up this encoder 2 here, needs to be configured for 78 millimeters. Wrong picture. So we continue on here. We're going to set up this encoder 2, which is the X3 port. Again, X3 port is setting up for incremental encoder. And we need to assign a resolution, 16382. That must match that of the slave. So as I said, the master is sending X10 emulation of encoder signal out of X10 to X3 on the slave. So if I go to the X10 emulation here, it's set for 16382. That must match, and therefore it's 16382. Likewise, on the X10 of the slave, this is set to 16382. It leaves and is emulated on X10 and comes back in on X2 right here, which is the 16382. So that is the complete encoder interface page configuration. And we'll save that. Okay, now we're going to move into the record table. And what we need to add in the record table is a way to start the slave gear in. And in order to do this, we add a record. I think it's under motion task, scroll, gear in, gear out. And we're going to do synchronous position absolute. Nothing else needs to be configured. And I always like to say what this is. And hit the apply. And therefore, whenever this whenever this record is executed, it will gear in to the mode synchronous position absolute. Okay. All right, the next effort is going to be on the MasterSlave page, which in this case it's going to be quite a setup. So the first thing that we're going to do is we're going to define the source for gearing. So this is going to be the X3, because as I said, we go back to the picture, this master axis right here is transmitting through X2. Let's see if I have a different picture here. Yeah, comes through here, comes through X2, is being emulated out of X10, and then X3 is what we want the slave to use to follow the master. So the X3 position, also called the the virtual master position. This is what the source selection is doing right here. And when we start to do our gear in, we need to have a tolerance of some sort. So unlike the defaults of 20 millimeters of tolerance to say that I'm geared in, so I'm going to change this to 2 millimeters, and then a velocity of 0.02 meters per second. And when we go to gear in, these values right here are the values used in the trajectory generator. So we can modify these based upon the application, but for right now I'm going to leave these more or less the same. 0.1 meters, 3 meters per second, and then we get down to the bottom configuration here. If I scroll down, so we want to be geared in at any point in time that I call that record. Okay, so this position diagram here, this is not necessarily specifically for a gear in with rigid axis. This is used for a variety of gear in methods, so we need to trick this a little bit here. So due to the fact that our defined position of reference point is 0 millimeters, and we know that the axis can't go beyond that, I'm going to say minus 3 millimeters is the start sync. And because our axis is 175 millimeters, I'm going to type in 190 here. So basically, if the axis is physically at any position between minus 3 and 190, and I execute this record right here, then the master, or I mean the slave axis, this slave here, will attempt to gear in. And these values over here, because they mean other things, for example, this here is when you end synchronization. I don't want it to ever end, so I'm going to put this at a value that's higher than anything else. And this one right here is the stop position. Again, the stop position is the destination where it must be completed. So between this range and this range, you have to complete this. I'm just going to put a number again that's very large so that it can never happen. Okay. And the master axis position is what will be coming through on the source here on encoder 2. So basically, whatever you see coming through as an actual position, which we'll see later, coming through on the absolute position of x3, which is encoder 2, you will see it coming through here. Come on, down here. Okay, the next step is going to be the parameter list. And we're going to be modifying similar parameters. So I'm just going to go quickly to there because I copy pasted something here. The group, sorry, operator parameter. So I'm going to copy this setting right here. Control A, Control C, and then I'm going to paste it over to here because I want to modify the exact same parameters here. I want to modify the encoder cross monitoring, which is 4643. If I scroll down, and again, we're going to have this as a 0.05, which is 50 milliseconds, 50. And then you can go smaller than this, like 0.0005, but again, it depends on your application and your velocities. This is basically 1 millimeter. So I'm going to leave it as 1 millimeter for now. And then additionally on the slave, I want to make sure that the hardware limits, even though we've told them that they're disabled, that they in fact are disabled, so activate hardware. So I'm going to turn that off, so that there's no hardware limit switch monitoring. Okay, and as before, if we consider the encoder cross wire monitoring, we're going to go to diagnostics and set up the error group or the error classification, and we want to find error 133. And keep in mind that let me just highlight this here and zoom in. So it's D1.07.2 and then 0013. There are other prefixes to numbers in here, so you need to find the exact one. It's basically this one right here. And what we want to have here is, I just want the error to be reported. I don't want the slave to actually react to anything. So I'm going to set this up as a warning so that it'll log the warning. Okay. And the next step is going to be the trace configuration. It's going to be more or less the same as before. I'm just simply going to delete everything that's in here and start adding trace channels. And for the sake of this video length, I'm simply going to pause the video and then add them all and then come back in when they're done. Because it's really unfortunate that you can't save these trace configurations. Okay, so I have configured everything here. I'll sit here for a second so you can take a snapshot of everything here, but this is basically the same thing as the master. And I'm going to save the axis, or save the project. It's saving both the master and the slave. And now we have modified everything for the master and the slave that are going to tolerate a master-slave position absolute sync application. And now we're going to move into commissioning. Okay, so first step in anything here is that we're going to download our programs. Okay, we've already configured our routing to our master and our routing to our slave, our axis right here. So as we said before, the master is the 185 port. I mean, that's the real-time port. The 185 and the 223 are the actual programming ports for the Festo Automation Suite software, which will match this right here. So when we simply go to connect, it will establish communication. Both of these drives were reset to factory, so they're as good as new as possible other than the IP address. And no parameter data, we're going to write to the device. Now that the device has been written to the volatile memory, we need to do a store on the device. I always like to check the telegram to make sure it has not been screwed up or anything like that. And it's still telegram 111, so that's great. So now we're going to go to the master and do the exact same thing. We're going to connect and do a download. Write the data. Now we'll store the device parameters. And sometimes you get this. That can be because the real-time port has a connection to the PLC. So I'm going to disconnect the PLC connection right now and do that again. Okay, store on the device. I don't trust the fact that it failed and it wasn't indicating it needed to be done, so now that's been done. I'm going to check the telegram for that. Telegram 111 is active, which is great. At this point, we clear all the faults, or try to. Acknowledge all the faults. Acknowledge all the faults. That can also be done on this diagnosis page here. Device state tells you what the errors were. You can acknowledge all button here. The error log tells you what errors there were at any point in time. Only online, of course. Okay, at this point we need to enable both axis, and I would like to talk about the control enable cross wiring for the master. Okay, so we've cleared all the faults, and let's look at the IO state here. Okay, IO state on both of them, and here's the ready contact right here. Okay, when there are no faults, then the ready C1 and C2 should be closed. Right now I've turned off the bypass here, and we need to make sure there's no faults. And we can look at that in this perspective right here. So the control enable is on right now. I'm not bypassing, and right now I have, on purpose, I've turned off the control enable to here, and I'm going to trigger a fault. Okay, so I'm going to go to the control here. I'm going to, well, I don't have to do anything. I just need to basically try to enable it because there's no physical control enable. And because there's a fault, I've lost the control enable over here on the master. I don't see why the ready C1, C2 are not being updated here, but that's just the way it is. I don't know if that's a flaw with the software, but basically the controller, the slave controller, needs to have no faults before the master can be enabled, unless the bypass is active. So I'm going to enable or acknowledge the faults here. I'm going to enable the access by the control enable, and now I have the control enable here, which means I can turn the master on. But as far as this goes, I don't need the control enable on prior to. I just need no faults on this side here. And now I can turn this on here, and the master is enabled. Okay, the next step is to home the master. So due to the situation, the master axis should be all the way to one end or the other, whichever one end that you've chosen to be the zero reference point. And if you need to move some things manually, you can disable the axis. I have a holding brake, so I click this button here, and now the holding brake is opened. And now by hand, if you look over here at the actual position here, I can turn the axis, which means I would be able to move the linear drive into position, and then you get it to a position where you are satisfied with it. You release the holding brake and enable the axis. Current position is homing. At this point, we could click Start Homing. So I'll home it. Now we have 0, 0, 0. Okay? And it has saved that 0 point automatically to the encoder. And this is done automatically because there's a little checkbox right here, activation save 0 offset. So if this was turned off, then you'd have to do that manually right here. So the offset's made permanent. So if we were to cycle power right now, because we have an absolute encoder, which is required for this master-slave sync, and we turned everything off, came back on, we would still be at 0. One other point to make right now is that the diagnostics is active for the encoder monitoring, and because we're in the commissioning stage, we will likely have to disable it, because right now the encoder is monitoring this absolute position and this. Well, because the slave is not turning, there's going to be no change in this right here. So if I try to do a move, even a jog, and try to move the axis, it's moved 2 millimeters, and now we have a position difference fault, and the axis is stopped with a stop category. So right now, because we're in the commissioning stage, this fault cannot be reset, because until we change the position, we're stuck. So at this point, you can disable the controller, do this, and then move this back to 0, so that we're within a tolerance of whatever the tolerance is. Now we've reset the fault. We put this back, and I'm simply going to go back to 0. Okay, we're back to zeros. If you need to move this axis for whatever reason during commissioning at this stage, then you can go to the error classification, go back down to the fault configuration, and temporarily take the error here and change it to a warning. And then when you're finished, before you do anything, put it back on. So you can disable this, but this is all we wanted to do at this point. What you might want to do at this point is confirm that the axis is moving in the proper rotation polarity. I've already done that, so if I wanted to move it past where we've moved it, I would change this to a warning again, like I said. But that's not necessary with my application right now, because I've already established everything. Okay, so at this point, what needs to happen is the physical alignment has to happen right now. So the master's been homed, and now we're going to position the slave at its position and align this permanently. And once we have established that, the next step is to home the slave. So at this point, we can say that we've homed, or we've physically aligned everything. And I'm going to turn the enable on here. So if I want to move something, I can. Right now, let's go to the control page here. And at this point, like I said, I can either enable the axis and move it, okay, by like under control, or I can disable this and open the brake. And now I'm going to position the axis so that it's identically or perfectly physically aligned with the master drive. So I've just done that, and now I'll reduce or remove the brake, so the brake's closed now. Turn the enable on, and we have a drive not referenced right now. Now we're going to start the homing. It's saving the homing data. Drive is now referenced, and we're at 0 with like a very high minute difference. Okay, and so this axis is at 0, the slave axis is at 0, The diagnostic state of the master right now is saying that there's a position difference. And why is there a position difference? Well, that's because as soon as we enabled the axis, the X10 on the slave started generating pulses to the X3 on the master. Okay, so now if I go to the master and go to the encoder interface, we'll see here that I move the axis 60 millimeters. Okay, so that's okay, because at this point we have the slave homed, we have the master homed, and the system is now ready for synchronization. Okay, so at this point I'm going to save the project. Okay, and in order to continue to the next step, which is to actually put the axis into sync, we need to have this position right here and this position right here the same on both the master and the slave. Okay, if we go to the slave, we're pretty close on the slave, but you know, we have an offset. So how do we get around this? Well, the simplest way to get around that, I'm going to store on the axis. I'm going to store on the slave. And the master has the problem, so at this point I'm simply going to disconnect from the master. Okay, and then I'm going to cycle power to it. And I'll do the same thing on the slave. I'm disconnected from everything. I'm turning power off to both the master and the slave. Power is being turned back on now. Okay, so after cycle of power, I've gone back online to each controller. I'm just going to clear any faults there are. Connected. Nothing here. One thing I noticed here is that there were some differences when I logged into the controllers. I simply did a read, and then I found that the IP address had been changed here on the multi-protocol drive. So make sure that that's a match. I don't know if this is a bug or if something in the future will be changed, but that's one thing I noticed. But the purpose of restarting was to get the encoder interface the same. Okay, so the absolute position here is equal to the absolute position there within the tolerance. Tolerance being 0.001, I think. And yeah, so at this point in time, we want to start the slave synchronization. And what we can do here is we go to the record table, and we can simply execute PLC control, or plugin control, sorry, and I can execute this. We're now geared in, and now basically wherever I tell the axis to go, it goes to 10 millimeters, and the slave's at 10 millimeters, and that's because the slave is following this position right here, the absolute position on X3. If we go to the master, look at the virtual master display, go to the active values at the bottom of this screen here. Active values, scroll down to the right. This value right here will be the same as what's in this value right here. Go back and forth. Yeah, 999, this one right here. And what we can also notice on the MasterSlave page is the fact that we are in this gear in section. So I can move it and we'll see the blue dot. Let's go really, really slow here. Execute. It's moving. And we'll see here that the blue dot is moving because, of course, the master position is changing, which is being sent from X10 on the master to X3 on this slave. And we're going to remain in sync here. We're geared in. And if we double click on this, slave synchronization complete. If we double click it, it tells you, it's got this little text on the end of it, but basically we're complete and we're still geared in. What's missing here is the ability to manage the fault recovery, error recovery, and the encoder differences. So this is all going to be taken care of the PLC program. What we could also add on the slave, or even both, we can go up to the watch window here and we can add a parameter 1.171. That is telling you that the gear in and out is active. And there's another one, I think it's 85607, which is what we're already monitoring in the extended process data, 85607. Yeah, so it's telling us the slave synchronization is complete, which is what this is right here. Yeah, 85607. So we can see that at any point in time. And it just helps us understand what's going on. Other troubleshooting we can do in here is not much. So what we need to set up in the PLC is we need to set up the master position right, so that when we have a power off, power on, anything along that line, that we align the encoder that's on the motors, which is the X2 port right here. Then we need to align this position here with what the position is right here. So right now, because we started with controller power off, this was absolute position 0 because we had homed it, and we started with 0 there because it's an incremental count. When you power off, power on, it's not saving the data, so you have a starting point of 0. And from that point on, if the positions become different, then you need to apply a master position offset. So this will all be covered in the PLC program, which is the next step.